So what does L'Hopital's rule actually say? Well, if you have limits that are of the form 0 over 0 or infinity over infinity, those are indeterminate forms, then the limit as x approaches a of f of x over g of x is the same as the limit of f prime over g prime. If this right-hand side limit exists, and it can be plus or minus infinity, those are okay. We need to have g of x not equal to 0. And then this statement as x approaches a also applies for one-sided limits here, and then also limits at infinity. Now, warning here, you want to do f prime over g prime, not a quotient rule. So let's look at some examples. We want to look at the limit as x goes to infinity, 3x cubed plus x over x cubed minus 1. So as x goes to infinity, so does 3x cubed and the x here, so the top is approaching infinity. And then the bottom, x cubed goes to infinity minus 1, that's also approaching infinity. I'm going to write the indeterminate form underneath the equal sign, and for written work, I'd like you to do the same. I'm going to put a little L above the equal sign to remind myself that I use L'Hopital's rule between these steps. So this will equal the limit as x goes to infinity, and we're going to differentiate the top, so 3 times 3, 9x squared, and then derivative x is 1. In the denominator, derivative x cubed is 3x squared, and derivative 1 is 0. Now, this is still an indeterminate form. The top and the bottom are still approaching infinity. But we can apply L'Hopital's rule again. So if you still get an indeterminate form, you can keep applying L'Hopital's rule as long as you finally get a limit that exists. So this will be then the limit x approaches infinity. Derivative 9x squared is 18x. And derivative 1 is 0. And then derivative 3x squared is 6x. And then those x's cancel, and 18 divided by 6 is 3, and the limit of 3 is 3. So as long as you keep getting indeterminate forms, that's okay, as long as you finally get an answer. And then here's the limit we asked about at the beginning of the section, 1 minus e to the x over sine x, so that one is form 0 over 0. That is one of the indeterminate forms for L'Hopital. And oh, by the way, this is L'Hopital, that's French. It's not La Hospital. The H is silent and the S is silent. Lots of silent stuff in French. Used to tease my students and say, if you say La Hospital, I'm going to put you in the hospital. But yeah, it's L'Hopital. And so we can differentiate top and bottom here. It'll be limit x goes to 0. Derivative 1 is 0. Derivative negative e to the x is negative e to the x. In the denominator, derivative sine x is cosine x. And now these are both continuous functions. Denominator is not equal to 0. This is now negative e to the 0 is negative 1 on top. Cosine 0 is 1 on the bottom. So that limit is negative 1. So where before we had no idea how to do this limit, now we can do it with L'Hopital. Now this one up here, as x goes to infinity, that one, we could do that one before. We looked at dominant terms and we got an answer of 3, and that agrees with L'Hopital. Here, this last example, we want to look at the limit as x goes to infinity, 4x cubed over e to the 3x. So both the top and the bottom are going to infinity, so this is infinity over infinity. We want to know, well, who goes to infinity faster? Sort of race to infinity. Well, remember here when we were comparing powers and exponentials that the 4x cubed is much less than e to the 3x. So my intuition is that the bottom gets bigger a lot faster, and this ratio will go to 0. But let's use L'Hopital to verify that. So this will be limit x goes to infinity. In the numerator, derivative 4x cubed is 12x squared, power rule. And derivative e to the 3x is e to the 3x, and then times the derivative of that inside function 3. So we can cancel the 3 into the 12. We've got a 4x squared in the numerator, but this is still form infinity over infinity. Top and bottom both going to infinity still. So we can use L'Hopital again. Limit x goes to infinity, and now we'll differentiate separately. So 2 times 4, 8x on the top. And then e to the 3x times 3 again on the bottom. So notice we keep getting exponentials back on the bottom, but the top, the power goes down. So this is still infinity over infinity, still indeterminate. So we're going to do L'Hopital one more time. Limit x goes to infinity. Derivative 8x is 8. And then derivative e to the 3x, e to the 3x times 3. There's already a 3 out in front, so 9 e to the 3x. And now this is no longer indeterminate. The top is a number and the bottom is going to infinity. So this is form number over infinity. So fixed number, bottom's getting bigger and bigger. This ratio does indeed go to 0.